been quite a stormy night. My name's Bob Hill. I'm the Director of the Environment Institute here at the University of Adelaide, and it's a great honour tonight to be able to introduce Professor Hugh Possingham. I'll give you a very brief summary of Hugh's extensive career. Most of you probably know that Hugh was born in Adelaide, did his first degree here in applied mathematics, and then his DPhil at Oxford University while he was a Rhodes Scholar. He proceeded to postdoctoral positions and fairly shortly after that was appointed to the University of Adelaide, first as a lecturer and then quickly working his way up in 1995 as full professor. In 2000 he moved to a chair in the Departments of Mathematics and Biological Sciences at the University of Queensland, and in 2001 he became the Director of the Ecology Centre and held a succession of Australia's most prestigious research fellowships through that time. He was elected to the Australian Academy of Science in 2005. And then, coming to tonight's topic, in 2016, Hugh became the Chief Scientist of the Nature Conservancy, which is the world's largest non-government environmental organisation. His expertise is in ecology, applied mathematics, spatial planning, operations research, and economic instruments for conservation outcomes. He's co-authored more than 600 referee publications, supervised more than 80 PhD students and 50 postdoctoral fellows. In 2016, he was elected a Foreign Associate of the US National Academy of Sciences, and he's just flown into Adelaide and is due to receive a very well-deserved honorary degree at this university tomorrow. And I'm very pleased he was able to include this seminar in what is a very tight schedule. So it gives me a great deal of pleasure to introduce Professor Hugh Possingham.
Thanks. Thank you very much, Bob, and it's great to be here. Hopefully that's not too loud, that's about right. It brings back lots of memories actually standing particularly here, because my first job was a lecturer in applied maths in the building over there that doesn't exist. It was red brick, believe it or not, in a little office on the 3rd floor where people argued about how much the length of your carpet was in your office was the main point of discussion at departmental tea time. But my first lectures were Mathematics 1 in the Horace Lamb Theatre in late February to 200 engineers. That was not good. In 1990, there were paper planes. There was lots of talking. It was almost uncontrollable. And because we had 4 versions of it, I had to do it twice. Somebody else did it twice, and the other person doing it twice was strangely not as boring even as I was. And so this was filled, and there was people everywhere on the ground and floor, but it was still horribly disruptive. At one point after my 5th lecture, and I'm now quite young, and everybody in the room seemed to be 3 inches taller than me. I don't know what engineers in Adelaide were doing in the 1990s. They were eating a lot of meat. And I just said, right, you're annoying me too much. If you talk anymore, I'm walking out. And they did, and I left. And I said, whatever was going to happen in the rest of that lecture is definitely going to be in the exam, and I'm not going to tell you what it is. And then the rest of the year went much better. So yes, slightly traumatic experience for an early career lecturer, taming engineers and teaching them matrix algebra and basic calculus. Anyway, hopefully nobody will walk out. Hopefully I won't walk out. I'm going to try and talk for about 40 minutes and give plenty of time for questions. And really, this is a talk that I haven't given very often. It's my new talk. If I was giving my normal talk all about Hugh and decision science, it would be one talk. This is really about TNC science and the kind of different things that conservation organisations are doing, very different from traditional conservation activities. So I think the Nature Conservancy, it started in the 1950s, was founded by the Ecological Society of America. It's a very old NGO. It's the biggest in terms of financial input. It's roughly $1 billion Australian dollars a year, the entire organisation, working across 74 different countries. It expands out of the US, and the heart still is largely in the US. But it is spreading, and it came to Australia just about 10 to 12 years ago, and I know it has projects out here on shellfish reefs and shorebirds. but you'll see a lot more of it as things progress. It's not a huge part. The Australian organisation is only 20 people, and my role is all around the world. But I'm just going to give you some snippets of the kind of things that we're doing that are a little bit different from what traditional conservation would be. And let me say that I won't talk about the heart and soul of the Nature Conservancy, which was really just a land trust. And so over the years, the Nature Conservancy has basically bought or acquired 2 or 3% of the entire United States, which is slightly expensive, much of which they have then passed on to other organisations, other land trusts, or to the Park Service. So they used eco-regional plans, they made strategic acquisitions, and they were very much a land protection agency for their first 30 or so years. And we still do a lot of that, and we're still buying land, and we actually bought a huge property in the middle of the Murray-Darling Basin very recently, the Great Cumbung Swamp, and with Indigenous people we'll manage that as a protected area. But a lot of the stuff we're doing now is we've sort of realised you can't buy your way to a protected planet. Buying preserve after preserve all across the world, and for a US organisation, buying preserves in countries like China, Indonesia, and Uganda doesn't always go down that well. So we spin off a lot of other land trusts, but we also have to think of different ways of doing things, and that's what I'm really going to talk about. We have a mission, we have lots of glossy pamphlets, but this is sort of the general history. The membership is very small, so we have less staff than, say, WWF. We don't have nearly as many members. The bulk of our money comes from individual philanthropists. I have never met so many billionaires in my life. It is amazing how many billionaires there are, and it's amazing how generous they are, particularly in the United States. And many of them are giving us $10 million cheques every year to do our work. And we do a lot of science. I'm the chief scientist. We have 350 scientists that are scattered across these states and countries. And it's a bit like, you know, saying, do you manage these scientists? People say, and I say, does anybody manage any scientist? Bob, does anybody manage? You know, some of the people in the room here I know are great scientists themselves involved in conservation. You just can't manage them at all. So I push and nudge them and steer them and try and help them as much as I possibly can. And we do publish a lot of science. So this year, in fact, it's 2008, it was 318 peer-reviewed papers came out from our scientists. So they're not only just doing the field work and doing the prioritisation and doing the science that helps our strategies, but they're also managing to publish some stuff in the peer-reviewed literature. This is me. This is my entire career on one slide, and this is all I think that life is all about. It's 31 one-syllable words. So this is what I bring to the Nature Conservancy, which is that obsession with being a mathematician and learning about optimisation and decision science and economics, and starting to impose those views on the world of conservation. So decision science runs the planet. You may not like that, you may like it, but it's true. They run the finance system, they run the engineering system, they run the transport system, they run pretty well everything. Decision science is no more than how do I make a good decision? And you can do that just by saying in the morning, should I have brought my umbrella today? Bob says yes, it's going to pour down with rain at 6 p.m. Who didn't bring their umbrella today? Some people didn't. Well, you didn't either read the weather forecast, you were optimistic, you missed it, or maybe you decided, like I often decide, that every time I take my umbrella everywhere, I lose it a third of the time, and that costs me $5 because the average umbrella is $15 and I'd rather get wet. More importantly, my wife, who will come late to this talk, will yell at me. And so I'd rather get wet than be yelled at. So I'm doing a decision science problem. That's decision science. You do it every day. You decide what to eat at a restaurant. You do big things like decide whether to buy a house or not and what interest rate to get. So decision science is everywhere, and that's all I try to do in my work, is to bring the rigour of decision science to conservation. And that's what decision science is. What do we want? What are we trying to do? What are we trying to save species? Are we trying to sequester carbon? Are we trying to improve air quality? Are we trying to improve reduce the nutrients that are going in St Vincent's Gulf? What are we trying to do? What's our objectives? And we first have to agree on that. That can take years. It can take a long time. And once we've decided what we want, then we line up all the things we do. So here in Spencer's Gulf, we're putting in artificial reefs. Is that a good thing to do? It's going to hopefully clean up some water quality, provide some habitat for fish and other organisms. Is it expensive? Yes, it's expensive. Is it the most cost-effective thing to do of all the other things we could do? Maybe, maybe not. So we could compare it to a whole heap of other activities. What's the modelling that tells us the benefits of those actions? What are the benefits in terms of biodiversity? What are the benefits in terms of nutrient reduction? What are the benefits in terms of improved recruitment to local fisheries? Can we quantify any of them? That's called modelling. Okay? You cannot make a decision unless you're a modeller. Modellers predict the future. Therefore, you're all modellers. Otherwise, you wouldn't even get out of bed in the morning. You can use mathematical models or you can use other predictive models. But you're all modellers because you're all predicting the future, so we need models. That's sentence number 3. Sentence number 4 is algorithms. How do I pick between the alternative actions using my models to give me the best outcomes? And then, ideally, that's usually where I used to stop as an academic. Now I'm in an environmental NGO. We go and do stuff, actually take action on the ground. And then in theory, those of you who know your natural resource management well, we're meant to do adaptive management. We're meant to see whether it works, monitor and learn. And those of you who know a lot about natural resource management know that virtually never happens. But we try and we talk about it and we get slowly better at it. And more you see in the literature, in the conservation science literature, much more of evaluation of conservation interventions on the ground, policy interventions, market mechanisms, and that's exciting because I think we are slowly starting to learn what works best where. That whole field of evaluation is important. I've made a lot of my career out of spatial planning for protected area systems, and now we're developing that into a broad-scale spatial action mapping process, and that will come out in some of these examples. Let me now go back. So much of this work is not me. Much of this work is amongst our lead scientists. This is our lead scientist for strategy and innovation, Heather Tallis. She's both quantitative ecologist and also a very good social scientist. And one of the things to set the framework of what the Nature Conservancy does and how we set our objectives, quite a few of our board, we have a large board of 30 people, were saying, you know, is this all a waste of time? I mean, if there's going to be 10 billion people, there's another 2 or 3 billion, maybe 4 billion people, many of whom will be in the Middle African countries. If we're going to continue to grow the GDP, if demand for food grows above and beyond just the number of people, because we're consuming more, and we have to consume more because many people don't have enough food, and those energy demands grow like that, this seems like, from a conservation perspective, this sort of seems all pretty futile, doesn't it? I mean, we're not doing well now. The extinction rates are 1,000 times the background rate. Isn't this all futile? Well, they did a lot of modelling, they did a lot of analysis, and they tried to work out, well, no, it isn't futile. This is business as usual, BAU, business as usual. I hate acronyms, I apologise, not my slide. They said by 2050, if we just keep doing what we're doing roughly now, and I think Australia as a continent is doing bugger all for the environment. We see that through our politicians at state, and there's a few good ones, but generally we're on business as usual path. We get, by 2100, 3.2 degrees. Most people now think that that's unavoidable, at least 3 degrees Celsius. This is the atmospheric CO2 associated with that. A lot of continued air pollution. Most people know that 15 million people die because of air quality problems every year. 15 million people die every year because of air quality problems. I mean, here in Adelaide, I remember growing up, you know, there was too much backyard burning, there was a bit of smoke and we all complained about it. But that was killing us, and it's still killing lots and lots of people around the planet. So these are all the things that are going wrong, and if we don't pay any attention to them, these are the consequences in terms of water consumption, industrial water consumption, a whole heap of bad things. Some of these are good things. So this is fishery landings. This would be good if it was high. And what we then did, and what Heather and her team did with a whole heap of economists and modellers and ecologists, they said, well, if we did everything properly, if we actually got all our fisheries sustainable, if we had all our fisheries sustainable, we would have a lot more fish. We would have a much bigger protected area system. We'd have 100% fisheries sustainability. The energy footprint would be actually bigger, unfortunately, so we've got to sacrifice a lot of land for solar, wind, and to a certain extent a little bit of hydro, so that's not so good. But if you follow all these things through, we end up in a reasonable, livable world. And even with 11 billion people, 10 or 11 billion people. So it's sort of an important analysis because it says don't give up all hope, and you can have your cake and you can have most of your cake and eat it too. Most of your cake, not all of it, but most of it. So that then allowed us to prioritise our global strategies, and these are the 5 things we do. And everything, all our 47 major strategies across these 74 countries all line up under these priority themes, and they're fairly simple. Protect stuff, tackle climate change. We do a lot of this. You don't necessarily think this is an environmental NGO's job. Why do we do so much of this? We've just actually embarked into a relationship, and this is going to make a couple of people unhappy, with Syngenta. Syngenta, there's 3 big, massive agrochemical countries in the planet, and Syngenta is one of them, and we're in a partnership with them to stop putting so much pesticide and herbicide onto their fields and stop selling it and go towards integrated pest management. So these are risky partnerships. We'll be a partner with anybody if we think they can change their practices. We're moving more into cities, which we never did before, and we also obviously believe, like everybody here, that you actually have to give people some empathy for nature, otherwise they won't care. So I'm going to go through some of these innovative processes and solutions we're trying to work on, and I'm not going to focus a lot on the on-ground work. I'm going to focus on the more innovative things. So one interesting thing is that if you look at the world's stocks, fish stocks, and you look at the big ones, the story's actually not too bad. People complain a lot about overfishing, but if you look at the big things, and Australia's been good at this, and quite a few other countries, European countries, some European countries have been good at that, this total stock biomass is sort of stabilising and starting to turn a bit up. Why? Because they have a whole heap of government regulations, size limits, catch limits, a lot of modellers and statisticians doing stock assessments. They do a great job here at SARDI on those sorts of things, been doing it for a long time, and we're actually seeing the corner turned. But there's another almost 10,000 fisheries that are little fisheries. So we're working on sea cucumbers in the Solomons. We're looking at mixed coral reef species near Bali. There's 10,000 small-scale fisheries, and they're collapsing, and they're too small. They're not going to afford to have a stock assessment. They're not going to have a lot of scientific evidence and monitoring. They don't even have a top-down control process. And so how do we get them to be sustainable? They're feeding 300 million people around the world, 300 million, and they're going down the toilet. So through one of our partnerships, this is the partnership actually including Australian organisations and NOAA, TNC, and through our program called Science for Nature and People, SNAP, we got some of the best people in the world who think about stock assessments, and they said, how could you work out a way of doing a really quick and dirty stock assessment for a small-scale fishery in like 2 months with the community and get it implemented and get them to change their policies, put in marine protected areas, change their fishing practices, community by community. And they worked out a system of doing that. So it's like a big proper stock assessment for a proper fishery can take months. This is like the back of the envelope stock assessment with a bit of an Excel spreadsheet attached to it. So there's a whole heap of questions you put in that you need to put in to understand a fishery about biology, governance, markets, some data. You then look at all these options. These are the action choices you can make, and you run them through these really fairly messy, rubbishy models, and you provide them some advice, and then you give them the mechanisms to test whether it works. And so we're rolling that out. We've rolled it out across Peru. We're rolling it out in parts of Indonesia, and the hope is that through influencing educational institutions and by example we can get those 9,500 fisheries sorted out in the next 20 years. That's feeding 300 million people with fish protein, which is, if it's done well, fish protein's great. I mean, it is a very sustainable. If it's done well, it's usually not done well. I just talked about the disaster of air quality. India has terrible air quality, and we might sit here and think, is that because they have they're burning too much Australian coal? Well, sometimes it is, but sometimes it's actually, they double crop in a lot of this part of India, north of New Delhi. This is a very warm part of the world, and they go between rice and wheat, and they get 2 crops a year. Rice when it's wet, wheat after the wet when it's dry. And at the end of the rice season, they burn the stubble, much like, again, those people are old enough like me remember when we were young, sitting in Adelaide, you could smell the smoke from the people burning the stubble just from sort of Roseworthy and Gawler, and the smoke would come down. Well, we stopped burning stubble, fortuitously. They still do it. And the problem is it's the easiest way for them to clear their fields so they can plant the wheat. And the thing is they don't have a lot of mechanisation, and most of it's by hand. So if you're going to do it by hand, do you want to burn it or do you want to sit there with a pick? So we're providing market mechanisms, and we're renting them out this thing called the happy seeder. See, is that good marketing? Happy seeder, and it does no more than plant a crop in stubble. But it can be shared. 100 farmers can move it around, and then we're actually trialling here behavioural economics. So this has existed for a while, but nobody took it up. What incentives, what marketing, what small payments can we give them to incentivise them to do this, and how can it spread among what is actually something like 50,000 farmers that cause New Delhi to be almost unbearable? Yeah, I think it's largely in January and February, when it's basically, or was it November, when you virtually can't breathe in New Delhi, and it's all just because of stubble burning. So the work there is actually largely behavioural economics work with agricultural work. The other work we've been doing a lot of is what we call natural climate solutions. Many of you will know about, is tackling climate change simply through stopping people destroying natural habitat. I spent a lot of time in Queensland trying to stop that, and it worked. Then Campbell Newman came in and it didn't work. And now it's working again. We went from 500,000 hectares of clearing down to 50,000 hectares of clearing through a Labor government. The Liberal government came in and they went up to 350,000 hectares of clearing. That clearing in Queensland, believe it or not, that was 10% of Australia's greenhouse gas emissions. 10% of Australia's greenhouse gas emissions. Economically almost entirely useless, probably cost the country money. It's the equivalent of taking half the cars off the road when we stopped that. So we did stop it, reversal government, we lost it all, and now the current Labor government is putting in those things. So protection matters a lot. That's a lot. That's half the cars. If Australia can get its land clearing problems under control, which South Australia did a long time ago, we save a lot of greenhouse gases. Restoring ecosystems, of course, and improving agricultural practices are very important for getting methane, reducing the amount of methane and carbon dioxide that come out of agricultural fields. The lead scientists who have been working on this are both in the United States, and they're credit for most of this work, and they've just released a large paper. It was a middle of last year that just tried to quantify if everybody did all the natural climate solutions, all the restoration, all the agricultural improvements and all the protection we could, how much of the entire climate change problem could be solved just through that, not through improved efficiencies, not through moving from oil and coal to renewables. And it ends up being about a third of the solution. A third of the entire climate change solution up until 2050 can be delivered just through nature. Or as people often inanely say, you know, what's the best solar panel in the world? It's a tree. What's the best way of converting solar energy into something useful? There's quite a few of them out there somewhere. How many plants? 300,000 plant species have worked out how to do it somewhere. This is actually the work, and this is more going into the detail of all the different agricultural practices, biochar, trees and croplands, agroforestry. These are all forestry issues, various forms of wetland issues. Of course, a lot of the wetlands have per unit area have a lot of carbon dioxide emissions and methane emissions. And then the analysis says if carbon was costed at $100 per tonne, the carbon benefits would be 11.3 petagrams. Who knows what a peta is? This is the only thing I hate about this slide. Nobody knows what a petagram is. 10 to the 15. Should have done those maths lectures. 10 to the 15 petagrams, and I wish they'd just say it's actually in normal English that's billions of tonnes, isn't it? 11.3 billion tonnes. Anyway, there you go. That's what you get if you do all those things, and there's that much price on carbon. All these things on the left here happen all the way up to there. They all automatically happen. Then if you want to do more, you can do, but it's going to cost you more than $100 per tonne. Some of them, you get quite a lot. Avoided forest conversion, well, sort of obviously, that's where you get the cheapest gains. Forest conversion is the stupidest way to put carbon dioxide in the atmosphere, quite clearly. We've known that for a long time. And then you get all these other benefits, air quality benefits, biodiversity benefits from different strategies in different places. So that has had that paper at a global scale has starting to influence global policy, and then we're drilling down and working with country by country, showing them what are the best activities to meet their carbon emissions through some of these relatively cheap mechanisms. And this is the graph. This is the sort of historic emissions. This is where we're going with business as usual emissions, petagrams again, or billions of tonnes of carbon dioxide per year. This is the bit. This is the 37%, this green bit, which we get through natural climate solutions. And so it's quite a lot of what we need to do to get. We still have to do many other things. Natural climate solutions are not the solution. They're a third of the solution to getting ourselves onto a 2 degrees Celsius pathway. Again, most people now tell me that 2 degrees Celsius would be very optimistic. And then the thing is, how do we turn these now into action maps? It's all very well doing these accounting where's the best places to do these things? So they've been doing a whole heap of analyses at different scales, and we're drilling down country by country and working with individual countries and telling them where are various kinds of restoration going to deliver the greatest return on investment. And so this is where reforestation should deliver a lot of benefit. I don't really believe some of those things, but there you go. This is where actually global scale analysis, I have to say I've done a lot of them, but they can get a little bit dodgy when you get into the details. You really need to do state or country scale analyses. This is urban reforestation. This is places where reforestation in urban areas would actually deliver quite substantial benefits. Improved fire management, something that is happening a lot in this country, particularly in northern Australia. If you can get the traditional fire regimes back, that has enormous carbon dioxide benefits, and that's true for a lot of the United States as well, avoiding those very, very hot, catastrophic late season fires that occur in many parts of the world through more continuous small-scale burning. Things like improved grazing, a whole heap of agricultural practice changes that will actually deliver carbon dioxide benefits. But again, they're patchy, so it all depends what's happening, what's the climate, what action can take. So these are what I call spatial action maps, and this is where the Nature Conservancy brings its science and its economics to bear with the community and the states and the people who are the land managers, and tries to help them decide what are the best things to do in what particular locations. Another interesting project, and this is Joe Kiesecker. He's our lead scientist. He's now the lead scientist for Protect Land and Water. And he's been doing quite a lot of what we call development by design. And there's a lot of energy that's produced and impacts natural environments. Of course, coal seam gas does that, but also in a lot of the United States particularly, but other parts of the world, wind power and solar power can go onto forests. So in the eastern United States, they're actually already clearing quite substantial forest areas to put in solar panels, which is alarming. Alarming for many reasons. First off, the payback time in that part of the world for a solar panel, if you want to pay back the energy you put into getting the road in, building the panels, deploying them, everything, it's about 4 or so years, maybe. If you clear a forest to do it, it adds another 4 years to that payback time. So this development by design work is us working again with states and regions to look at all their energy needs, renewable energy needs and non-renewable energy needs, and work out where to spatially locate them so that they get the best outcome in the long run. Should they have hydro? Where should they have hydro? So we're working in Peru. Peru wants to dam a whole heap of rivers that go into the Amazon to produce all the power for eastern Peru. And we don't think that's a good idea. So hydro's fallen down on the list of environmentally acceptable. Also, if you drown forests, the methane production is enormous. It's enormous if you drown forests. So we're trying to convince them that they could do a lot more with wind and solar and have far less impact on the environment. So we look at things like India, for example. We look at, you might think India is full. India is amazing, there's so much in it. But there are a whole heap of wastelands, and there are a whole heap of wastelands where if you look at wind and solar, these are the places where they could actually use relatively poor quality agricultural land or abandoned agricultural land and actually deliver good outcomes in terms of climate solutions. And then finally, Joe does a lot of this traditional work, which is where do we build protected areas? So Mongolia has massively expanded its protected area system in partnership with the Nature Conservancy. But instead of us flying in, we have a Mongolia program, we've been there for 15 years, and saying, hey, Mongolian government, you need a proper representative protected area system. We said, where do you make all your money? Where does Mongolia make all their money? They make it out of mining. About 80% of it, probably more by percentage than Australia. They are still going to keep mining. They want their children to go to school. So they're going to keep mining. We work out where all the mining places are, and then we then try and build a portfolio of representative protected areas around the interests of the mining. And that has then given them the confidence to progress forward with a new protected area system, and that's some of the blue. That's now heading up to now, this was done with the spatial planning tool my lab developed long before I joined TNC. And they think they'll meet 30% protected areas in the next 15 or 20 years in Mongolia. This is an interesting one. So this is debt for nature swaps. Now some of you will remember debt for nature swaps, and they were quite popular 20 or 30 years ago when there were various Latin and Central American countries that were in debt, and European and American governments would swoop in and say, if you stop clearing your forests, we'll forgive a bit of that debt or give you lower interest rates and do all these deals. And generally they fell to pieces because they were seen as very much too much. Indigenous people weren't consulted, local people weren't consulted. It was very much, we're the West, we've destroyed the planet, now we're going to pay you a pittance to stop development so that you don't keep destroying the planet like we did. So it wasn't great, didn't go so well. We've started that again, we're doing it in the sea. And so where we're doing it in the sea is we're looking at a whole heap of countries, and the first one we looked at is the Seychelles. And we look at those countries that have a large debt. So this is the country's debt, and in that case we're talking not in some senses huge, but like $100 million. And when you have $100 million US dollar debt for a small country, that can be crippling. And they're paying that debt at some horrible interest rate to some horrible bank at, say, 12%, and they're defaulting on their loans. And it cripples their economy because their interest rate then keep going up because they keep defaulting on their loans. So they've got $100 million, they're paying 15% a year, and we go to the bank or the creditors and say, hey, you're probably not going to get this money. What if we give you $50 million now, cold hard cash? We'll give it to you now and you walk away. So that's what's called writing off bad debt. Some can do it, some can't. We restructure the debt, we get philanthropy, some of these rich people to give us $20 or $30 million. We restructure the debt and we create a supply of income and basically give them a $20 million debt at 5% instead of a $100 million debt at 15%. So we basically secure their debt and restructure it to a much lower level. Well, what's the deal for nature out of that? What's good for the Seychelles? And this is a map of where we're looking at a whole heap of other countries where we can do it, particularly in the Caribbean, South Pacific and Africa. What's the deal for conservation? They have to build a marine protected area system that's roughly 30% of their entire exclusive economic zone. And for the Seychelles, that's 400,000 square kilometres of marine protected areas, some of which will be still fished to a certain extent, some of which will be true no-take marine reserves. And so it's 15% no-take marine reserves, 15% modified fishing practices with no trawling, and we're getting these big marine protected area systems. We just got another $15 million to look at other countries and start doing deals with other countries. A couple are in the Caribbean, and Jennifer, who's been working with me, has been trying to work out which countries are the best places to do these deals in the future. And it's not just an ecological analysis. We can look at the amount of coral diversity, the amount of coral reef, the size of the fisheries, and a whole heap of biological parameters. But we then, at the top of it, have to look at all these political, institutional parameters, like, do they even have a debt? If they don't have a debt, you can't do a deal. Do they have a debt to somebody that might be willing to pay it off? So apparently the World Bank cannot write down bad debt. So if you have a debt to the World Bank, you can't write it off. You can't write down bad debt. So there's a whole heap of socio-political factors in a decision tree that then sits on top of a cost-effective analysis that informs TNC strategy. And we're now rolling out, starting to roll out these. These are difficult deals. I was helping the South Australian government at times with the marine protected area system in the state waters here. I've done Moreton Bay, I've done the Great Barrier Reef, I've done Queensland, I've done New South Wales. I've had meetings with angry fishermen. I've had meetings with angry politicians. Building a marine protected area system, some of you in this room know, it is quite painful, quite painful. There's a lot of acrimony, there's a lot of anger. It's slow. So TNC think that we're going to get 20 deals done in 5 years. I tell them it's going to take you 20 years, but keep going anyway. This is fun. Changing topic completely. So that was all about high finance. This is sort of about microfinance. And this is a map of the United States. And I'm going to focus here on the Central Valley. This is done by the California TNC team. They've got a great set of scientists. They've got close to 40 scientists in TNC California. They're so good they just ignore me entirely. And there's the Central Valley. And you can see this is actually Dunlin, which is a small, slightly boring wader, shorebird. If they turn up in Australia, we get very excited because there's hardly any of them, but they're all over the place. And you can see what's happening. A lot of them in December and January are wintering in the Central Valley. Now that's great. About another 50 or 60 waterbirds winter in the Central Valley. Snow geese, huge numbers of ducks, sandhill cranes, heaps of waders. It's just teeming with birds. The only trick about the Central Valley, what can you say about that? The Central Valley feeds the entire western United States. Well, not quite, that's an exaggeration, but it is the food bowl of the entire western United States. It's almost entirely cleared. So what do these birds want? They want to turn up for 3 or 4 months in the winter when they're breeding up here. They want to turn up there. They just can't be bothered to go to Mexico, it's too far. So they want to sit there. They want some water. Well, traditionally, those paddocks were dry over the winter. What's the point of having water sitting in the winter? Nothing's going to grow in the Central Valley in the middle of winter. So we then took eBird data. eBird is an international bird database, very popular in the United States, becoming incredibly popular in Australia now. We looked at that data and we tried to identify which parts of the Central Valley we're going to deliver the biggest number and diversity of shorebirds and waterfowl. And then we did a reverse auction. So we went advertised to different parts of this Central Valley and said, how much money would you want if you were, from us, if you were willing to leave the water for 2 or 3 months at about 4 to 8 inches on your abandoned rice fields? And they put it, it's called a reverse auction because they then decide how much they want, and they might not want much at all, they might want a little bit. And they say, I want $20 an acre. I've got 400 acres, $800, $8,000, 400 acres, $20, $8,000. Can I have that? And then other people give us less. We take them all, and then we look at, from eBird, where are the best places, and effectively we create a temporary annual wetland for those birds, which is the cheapest place to put it. Reverse auctions have been used a lot in Australia, but the cheapest place for the year to deliver the best conservation benefits. So it's interesting, it's citizen science data, it's using a reverse auction, it's a temporary reserve, but the more it progresses, the more enthusiastic, and some of these farmers are now just starting to do it anyway. So sometimes you need just to get them over the hoop, and then they start thinking it's a good thing to do. There's all the bits of that process. It's sort of messy, but it works. It takes a lot of science and a lot of economics and a lot of goodwill. And there's some, I hope they're Dunlin, I think they Okay, I'm going to not go through most of the rest of the projects. I'll skip a little bit. The one that I think is quite exciting, and it's not so much about acoustic monitoring, but it is about the rainforests of Borneo. And this is stuff that hasn't even started. So this is the heart of Borneo. And the heart of Borneo was where a lot of the big environmental NGOs were quite obsessed with for a long period of time. And whatever analysis we do on a global scale, if we do analyses of concentrations of threatened species, Borneo, and to a certain extent Sumatra and Sulawesi, come out as the places to go. If you want to preserve a hectare of forest and you want to save as much biodiversity as possible, it's hard to go anywhere other than the heart of Borneo. But nobody was getting anywhere. So Eddie has been working with the Indonesian government and other people on acoustic monitoring, which is a science thing. How can I tell how healthy a forest is based on acoustic devices and picking up the signature of all the bird calls? But what he's actually now trying to do is we're going to buy entire forestry concessions, 300,000 hectare forestry concessions. And we're going to buy them through an Indonesian company, and we're going to manage them as a forestry concession. That 3/4 of it won't be logged, 1/4 of it will be logged, and the 1/4 that will be logged will be just very, very occasional light-scale selective logging. So that's not good. Why is an environmental NGO doing logging? If you don't do anything with it, it's going to turn into oil palm. If you make a protected area and exclude the community from any form of livelihood, they'll eventually actually move in. Some of Indonesia's national parks are full of people, and they will continue to be full of people. But if you buy those concessions, we run by an Indonesian company that we will control, and then you allow them to extract a livelihood from those forests at an acceptable rate, then we think over the next 10 years can buy half of the forest, conserve half of the heart of Borneo by helping Indonesian companies that we then control by forestry concessions and manage them very sustainably. So that's the plan there, and there's lots and lots of things about acoustic monitoring, and then we're doing all the science around it just to see that the logging isn't having a major impact on biodiversity. And these are places, of course, which have orangutans, leopards, clouded leopards, and maybe a few Sumatran rhinoceroses somewhere around, and ridiculous diversity of vertebrates and insects and plants. For the last one, I'll go into a tiny little bit, and this is a controversial one. It will be my last one. It's should we start insuring natural infrastructure? So we are a partner in a science organisation called the Natural Capital Project, which run out of Stanford. There's a lot of people who have become very interested in natural capital. I know there's people here who are interested in natural capital for a long time. So if you can start valuing natural capital, and in this case, if we have some tourist resorts and some houses and some coastal infrastructure, and there's coral reefs in front of it, and we then work out through a whole heap of hydrodynamic modelling that if there is a cyclone, hurricane, level 3 or 4 in that area, the presence of that coral reef, we can work out how much less of the land and the infrastructure is destroyed because of the presence of the coral reef. And it can be quite substantial. We're talking about tens, if not hundreds of millions of dollars of less destruction because of the presence of coral reef. And of course, most people remember Aceh and the benefits of mangroves, exactly the same. Okay, so mangroves, coral reefs, natural infrastructure, they reduce damage to infrastructure, the natural infrastructure that reduces damage to human infrastructure. Now, what normally happens to things that are helping you protect things, you want to keep them going. So one thing to do is you could insure them. So in Mexico, they're on the verge of insuring with a huge insurance company their reefs, such that, and it's called parametric insurance, and I'm going to probably get this wrong. Parametric insurance means as soon as the cyclone hits, they don't go out and assess the reef. If a cyclone level 3, they get this amount. If a cyclone level 4, that amount. And they get enough to rebuild the coral reef. You might say, can you rebuild a coral reef? They get a lot of money to fix up the coral reef as best as they can. So they rebuild the natural infrastructure through an insurance mechanism. And they get it. It's not like when your house gets burgled, you have to take photos of all the things that you never realised you had, and did they really take the video machine, and when did you buy that video machine, and where's your receipt? They just pay out straight away so they can get to work, and basically then they put in what is a mixture of an artificial reef, and then they start seeding it with corals and replanting with corals. So it's going to be not quite a perfect coral reef, but it'll be half concrete sort of infrastructure, but half then coral reef, much like these shellfish beds out there, but a coral system. So it's sort of, I find it, I'm not actually in this case, I'm not completely convinced that ensuring natural infrastructure is going to be a big game changer for the environment, but we're trying it and we're seeing if it works, and this is what happens if you have normal flooding. If the reef gets destroyed, they can. The modelling's the interesting thing. They can tell you how much more it costs when those reefs disappear, and this can be done with mangroves and other things. And there's a whole heap of valuations of coral reefs in terms of their benefits for natural infrastructure. So why not insure natural infrastructure? We insure buildings. Why can't we insure forests and reefs? I'm going to ignore all the city stuff because we don't want to talk about that. And I'll end with a slide of somebody doing something because we like doing things. That's not me. So I suppose what I want you to leave the final impression with is that the science of conservation is changing a lot. 20 years ago, the Nature Conservancy had 300 or 400 scientists. We have 300 or 400 scientists now. But 20 or 30 years ago, they were ornithologists, freshwater ecologists, and we still have a lot of them. But now we have engineers, we have economists, we have finance people, we have behavioural economists, we have a whole much more diverse group. Some of them came from a bit of an ecology background, but they have a very diverse set of skills, a lot of geographers and GIS people. And the science we're doing is always embedded in a business model. Nobody does any science where they can't explain to me, Hugh, if we work this out, then this management intervention will be more efficient, or this new management intervention can be deployed. So, you know, these insurance, we need to actually calculate the financial benefits of those reefs. Otherwise, you can't do the business case for the mayor in the council in Mexico. So it's a lot of modelling, it's a lot of quantification, it's a lot of stuff that you wouldn't necessarily say was traditional conservation biology, and that's the future of the discipline. I'm very happy to take questions. Thanks.
We do have time for some questions. I'm sure there will be some.
Okay.
So my question's not so much about the health of ecological systems,
Yes.
but about the health of the ecological science community.
Right.
And your perspective on this. And the background is, yesterday the Climate Council published a report showing how much the coalition had cut back on environmental science and stats around the place. And the Trump administration has been doing the same in the US.
Yeah.
So after looking at your career, would you say ecological science as a community, as a discipline, is growing or decaying, under threat?
Yeah, I mean, I think the government's investment in this country, I've seen the numbers. The Federal Environment Department spending has dropped, has halved in 20 years. And I would say most of the states are not much, but halved in real terms in 20 years. Yeah, there's no doubt about it. There's incredible institutions in the US like NOAA, USGS, who provide enormous amounts of global data that we feel is very much under threat. That said, you know, TNC by law cannot do more than 1% lobbying. So we're not in the news a lot because we're under a piece of legislation that gives us charitable status. That means that we can lobby a little tiny bit. So we are aware of these problems. The majority of those 314 papers last year, our biggest co-authors on those papers are US federal agencies. So we know their value. Two things are happening. One is most federal departments in the United States are just trying to do as little as possible. moving very, very slowly, making things sound very, very difficult. And so they're not, some are obviously resigned, some are just saying, I'm going to stay here and do as little as possible. So that's one way of hunkering down and hope that this thing disappears. I'd have to say, in Australia, I mean, it's not been really that good. I mean, there's moments of light, but there's generally moments of darkness. The investment in the environment departments, I think, has been poor. The investment in scientists in government departments, I think, is poor. And I've worked with so many federal and state government people, and the thing I see also is we don't want specialists anymore. We don't need an ecologist or environmental scientist, because you can just move from defence, and if you're a good public service, you can move anywhere. You can move from defence to health to Veterans Affairs. You're fine. No. Yes to some people, but no, if you don't have any disciplinary expertise in your environment departments, that is a disaster. And that's also appeared to be a modus operandi of modern government. So I think we need to fight them. I will say that for organisations like Packard, the Packard Foundation, they spent most of their last budget, they're a huge philanthropic fund, trying to organise the scientists to represent themselves properly. So the Ecological Society of America does a bit, but, you know, we are the worst people in the world in terms of pushing political influence. And so sometimes the philanthropy groups in the US are now just saying, you've got to just get your shit together, and you have to lobby as a group. You can't argue with each other anymore. You know, I know you're scientists and you want to argue with each other. You have to appear at the steps of the White House as a unified force. And this is where the National Academy of Science is useful, and the AAAS is useful. They have been galvanised by these events in the US. I actually think the same probably has to happen here. We've been destroyed bit by bit, death by 1,000 cuts. Eventually, I think we need to galvanise our forces in Australia and say enough is enough. Yeah.
Hugh,
yes.
do you have any examples in your work of getting people to use water sustainably?
Yes, we do. And we have a bit. We are in the water funds in the Murray-Darling Basin, and we have managed to buy and sell water and make a profit and then deliver environmental water to wetlands. I don't know how we did it, but we did it. The Australia team did that. So the one thing advantage, if you're buying water and you have almonds and grapes and stuff, you have to buy it when you need it. Environmental groups can buy water when it's cheap, when nobody else wants it. So we buy it and then sell it when it's rare. So, and also make so much money selling it when it's rare, we have surplus that we can put some water into places where it needs to be. So you can use the market when you don't have to keep an almond tree or an orange tree alive. The other big water thing we do are called water funds, and the best water fund we have is the Nairobi Water Fund, and it's worth Googling Nairobi Water Fund. So Nairobi's a big and growing city. It's a bit of a mess really, but most of the water comes off Mount Kenya and lots of small farms. These used to be tea plantations, and now they've been handed over to the people, and they've got 2 or 3 hectare farms. And it used to be quite catastrophic. An enormous amount of sediment and fertiliser going into the water basin that fed Nairobi. So we've now there's something like 200,000 farmers there. We've worked with 50 or 60,000 already to change their agricultural practices, and they're getting payments from the Nairobi Water Fund. So the water utilities in the state pay ecosystem services for change agricultural practices that reduce the sediments and nutrients going into the water, and it's profitable for the water fund, it's profitable for the water utilities, and of course it's good for the farmers, and sometimes it's double win for the farmers. Sometimes what they do is more sustainable. So we're deploying 20 or 30 water funds around the world. There's probably 500 or 600. It's particularly relevant. Brisbane, the water supply is Lake Wivenhoe. Most of Lake Wivenhoe's catchment is agricultural land. It has a few cows wandering around shitting everywhere. And it's amazing. This is a catchment that's slowly silting up, and it's full of eutrophication, and the value of the agricultural land is very low. They could just fence a whole heap of riparian streams and it would again be win-win. So there's to be honest, TNC, the modus operandi is here's where we are and here's where we want to be. And up there is good for everybody, people, nature and the economy. But to get there, we have to go through this dip, and that dip can be a financial dip or it can be a conceptual dip. And that's how we work, is we work out how to get through that hole, even though everybody sort of knows where we want to be. And it's amazing how often that's true. There's win-win-win solutions. Yeah.
So you mentioned that eBird
Yes.
science project.
Yes.
And obviously citizen science is also fantastic for building that nature-people connection.
Yes.
As well as getting fantastic data. So are you guys running your own projects or funding citizen science projects?
We do not.
Will you?
We might. I mean, Cornell runs eBird, and I brokered the deal that got eBird to come to Australia with various organisations, and now there's 60,000 lists have come in this year. 60,000 bird lists. It's coming in 10 times faster than it used to be coming when Birds Australia were running everything. So it is amazing when you liberate data. We think other people do that probably better. And you know, that's the other thing. We may, I suspect we won't get into citizen science too much. We use the data we have. The biggest danger for any environmental NGO is to think they can do everything. So I think we do some things that WWF, Wildlife Conservation International, local green groups, you know, we buy a lot of land and we hand it to local land trusts because we don't want 40 acres. We don't want 60 acres. We want 6,000 acres. So we have to think, what do we do best? And I don't think we do that best. But I do think it's incredibly valuable. Yeah. Yeah.
Do you think it would be beneficial for big organisations like TNC and CI
Yeah.
to become actual businesses rather than...
Right. Yeah. And we are a little bit like that because we have an arm called Nature Vest. So Google that, and that's basically us trying to create companies that do good environmental things, but there'll be spin-off companies. And we have another thing called Techstars, where we basically get 100 people to come up with great ideas, then we throw in a couple of $1 million, we develop those ideas, and 5 or 10 come out the end. You know, they do amazing things like robots that go down through the sewage systems, detecting everything and finding leaks and all those weird things that technical people do. So, but we trying to create a lot of those companies, but we probably ourselves won't be one of those companies, I don't think. But that's, we love the idea. Yeah.
Maybe one more. There was one.
Yeah, I was just wondering, just briefly, why does World Bank claim they can't write down bad debt?
I think it's in their laws and systems, and it probably is some way of avoiding corruption and a whole heap. I mean, writing down bad debt is potentially a corrupt thing to do. I mean, because you're losing stuff, and some big organisations can't do it, some can. Yeah.
Okay, look, thanks everybody. I really do appreciate you coming out this evening, and especially grateful to you for taking time to come through this. Please join me in